Hello students, welcome back to Chemical Kinetics. In this module, again, we will see complex and elementary reactions and the mechanism of the reaction and rate determining step, intermediate. So basically, whatever we have done in the previous module, we'll see some more examples on it. Take into consideration this reaction right here. 2N2O5 producing 4 molecules of NO2 and 1 molecule of oxygen. Here, this is a complex reaction, which means that it takes place in multiple steps. Consider step 1. Step 1 will involve some reactants, which will produce some products and an intermediate. So there you go. N2O5 produces 1 molecule of NO2 and 1 molecule of NO3. NO3 happens to be our intermediate over here. In step 2, this intermediate will react with the remaining reactant and it will produce the remaining products. So there you go, step 2. This is the reaction. N2O5 will now react with the intermediate and produce the remaining products. Now, what happens over here is that the formation of intermediate, as we know, is slow, and consumption of the intermediate, as we know, is a fast step comparatively. Slow step, as we know, is always the rate determining step. If you add up these two reactions, you get the same reaction as the one on top. As we have already discussed, rate law expression can be given in that manner. R is equal to K into concentration of N2O5 raised to 1. Because in the slow step, we have to apply law of mass action. Take NO3. It's getting formed and consumed within the reaction, so we call it the intermediate. Let's understand this with the help of one more example, this one right here. 3ClO minus giving ClO3 minus and 2 chloride ions. Again, it's a complex reaction. That means it takes place in multiple steps. These multiple steps themselves are elementary reactions. So let's consider step 1. Some of the reactants produce some of the products and an intermediate. Here you have 2 ClO minus reacting together to produce 1 chloride ion and 1 ClO2 minus. Now I want to make a guess as to what exactly is the intermediate here. Naturally, it is ClO2 minus. This intermediate in step 2, this intermediate will react with the remaining reactant and produce the remaining product. So there you go. This intermediate reacts with 1 molecule of ClO minus and it produces 1 ion of ClO3 and Cl minus each. Add up these two reactions. Step 1 will be the slower step and step 2 will be comparatively fast because ClO2 minus is getting formed in step 1 and consumed in step 2. Consumption of intermediate, as I told you, is always fast. Add up these two reactions and what you get is the same reaction as the one on top. And as we have discussed, if we have to write the predicted rate law expression over here, the predicted rate law expression, just take the slow step and apply the law of mass action on it. So we can say that R is nothing but K into concentration of ClO minus raised to 2, because you have 2 ClO minus ions reacting in step 1. ClO2 minus is getting formed and consumed within the reaction, so I can say it is the intermediate. So wasn't it easy, my dear students? Take the complex reaction, identify the rate determining step, and identify the intermediate. So let's take a multiple choice question to see whether we have really understood this concept. Your question is, the following mechanism has been proposed for a reaction A plus B giving C plus D. It's the slow step. A plus C giving E. It's the fast step. Add up these two reactions and you get 2A plus B gives D plus E. The predicted rate law expression for this reaction is, and your options are A, R is equal to K into A square into concentration of B. B, R is equal to K into concentration of A into concentration of B. C, R is equal to K into concentration of A raised to 2. Or D, R is equal to K into concentration of A into concentration of C. It's a really simple question, my dear students. All you have to do is take the slow step, apply the law of mass action. Which one is the slow step here? A plus B giving C plus D. And when you apply law of mass action on it, you get rate is equal to K into concentration of A raised to 1 into concentration of B raised to 1, which is nothing but option B in this case, and that is the right answer, option B. So I hope you understood this concept of complex reactions. See you in the next module. Till then, take care.